Hello guys, I am Mohammed Intakhab Beg and I am an automobile engineer and also an assistant production engineer and I am gonna teach you the material science. So in the material science there are many topics like phase diagram, dislocation theory, heat treatment, crystallography, X-ray diffraction, polymers, corrosions, ceramics, nano composite. But today we just introduce alloys, compounds and phase diagrams. This is our first lecture and again welcome to my material science lecture 1. And in this session we set the foundation for understanding how atoms combine to create new materials with tailored properties. And we'll discuss the fundamental differences between alloys and compounds, dig into the nature and impact of intermetallic inclusions and interpret phase diagram. Essential for predicting material behavior. By the end, you will understand how microstructural changes shape physical properties, paving the way for advanced engineering applications. So again, welcome in my lecture. So let's start. So let's talk about alloys. So if we talk about alloys, so basically alloys are created by combining two or more elements, usually metals. So everyone knows that if we combine two metal, then we can combine it by casting and something like that, and mainly we combine it in liquid state. So alloys are created by combining two or more elements, mainly metals. And the newly formed microstructure reflects properties of both base and impurity metals. So the main difference is that when we put impurity element in base metal, then that impurity metal make bond like it mingling with that base metal, and the resultant is reflect both reflect properties of both element, base metal and impurity element. And if we talk about its examples, it includes brass, copper plus zinc, and steel, and iron plus carbon. So and still we mainly see that uh, it reflects both carbon and iron's property. So the main concept of alloy is if we combine two metals, then the form metal or the resultant metal from both of these compound will reflect different properties. If we talk about advantages of alloy, then it enhanced strength compared to pure metals, improved corrosion resistance and durability, tailored melting points and mechanical traits. So the next is compounds. So mainly compound is when we combine two metal, or when we put some impurity in base metal, then both metal form in such a way that both element loses their existence. Both element loses their existence. So if we combine two metals, or if we put some impurity in base metal, then the resultant metal or the resultant com uh, component or element will lose their property, will lose base metal property and also impurity metal property. Okay, so that's the main thing. Like if we talk about water, H2O, so hydrogen is have different property and oxygen have different property, but we if we react both of them, then water shows different properties. And if we talk about salt, like if we talk about sodium, uh, only sodium, then if we put sodium on in the water, then there will be fire in that water. And if we talk about chlorine, it is very poisonous. So, but if we combine both of them, then this is the salt that we eat. So the compounds, the main definition of compound are that uh, if we combine both of metal like impurity and base metal, then the formed or resultant metal will be the will not show uh, will show a different property from both base metal and impurity metal. So I think, guys, you have understood what is the compounds are. So if we talk about intermetallic inclusion and machining problems. So intermetallic inclusion are those like small pockets of compound formed during sand casting due to turbulence and sand erosion. So you people have done casting in your college. So if they you have also seen that if we put metal in the sand during casting, so uh, I think you people have learned about turbulence and laminar flow, turbulent flow and laminar flow. So turbulence, when we put that metal in the in the sand during casting, so if we put it like very fastly or very frequently, then the flow is become turbulent, and uh, it like it affect the it what we can say it directly affect the that sand and form the pockets and react with that sand and form the pocket of compounds, because that metal react with that thing and become the compounds and form that pocket on that metal, on that resultant metal. So what is the machining impact of intermetallic inclusion? So when that small pockets on that resultant metal, then we machine it. During machining, there are abrasion wear, and that abrasion wear caused by inclusion. Like if we machining chipping or shortened chipping or something, then it can cause abrasion wear, and it affect the tool and shorten tool life cutting operations. So how we detect it? Typically visible under microscopic examination and influence material reliability. So let's jump out on another slide. So this is Hume Rothary rules for alloy formation. Hume Rothary and Hume was a scientist and Rothary was his student or assistant. They both combinedly make this rule for alloy formation. For, so, so there are three point of Hume Rothary rule. Like first is crystal structure match. Like both elements must have same crystal structure for extensive solid solubility. This is the main rule of Hume Rothary. And the second one is size difference and valency. So the valency are must be 15%. So atomic radii difference less than 15%, and valency should be identical for solubility. And the third one is electronegativity and electron affinity. So both have both value of electron affinity and electronegativity should be comparable. Like value should be close to facilitate atomic replacement without significant lattice distortion. So let's understand what is electron affinity and electron negativity. So electronegativity is the tendency of an atom's nucleus to attract electrons from another atom's nucleus. So this is the electron negativity, and electron affinity is describe how strongly an atom attracts its own electrons, affecting atomic size. If some material have more electron affinity, then you see that its size must be uh, smaller because it attracts its own electrons. That's why. Let's move on. So let's talk about strength and melting point. So alloys have increased strength, and alloys are typically mechanically stronger than their pure components. And if we talk about melting point variation, melting points can be higher or lower than base metals, determined by composition. And we can understand the melting point behavior and transition by phase diagram. So what is phase diagram? A phase diagram maps temperature and composition showing stable material phases. And it is mainly between and temperature and composition. So interpretation is reveals solid, liquid or mixed phase regions and melting points of alloys. And the crystal changes indicates possible shifts in crystal structure or unit cell size during temperature size changes. You know about the unit cell size is like FCC, BCC, all these about. And experimental techniques observed by transmission electron microscopy and X-ray diffraction methods. And these both machines are very costly, like it comes in crores. Let's move forward. So the main thing of phase diagram is it is classified into different types. The first type is uh, on the basis of component. So if we talk about on the basis of component, if there is only one component, then we call it single component phase diagram and unary phase diagram. If there are two component, then we called it binary and uh, binary phase diagram, and it is common for alloys like aluminum, copper. If we talk about ternary, like three components, then its example is like if we put sugar and salt in water, then there are three components, you know, the three compounds and the three components. Mainly components mm, are the mixtures. We mix things that are the components. It may be compounds or it may be element. Mm, Let's move forward. So I think today's lecture is completed. Uh, let's see you people in another lecture. We have a series of material science. Who don't understand it in a detail, we'll explain it in a detail. Thank you guys. Thanks a lot. We'll meet in another lecture. Thank you.